I'm Emily Bembenek. I run the Center for Applied AI, and I'm very happy to have with me today James Ross and Joe Bergera. They're going to be talking to you guys, having a nice conversation about Joe's work at Iteris and where he's president and CEO. And just to give you a sense of how the hour will go, I will let them have a great conversation. You're welcome to raise your hand if you have any questions. But for the most part, we'll save those till the end. And then I will kind of call on each of you at a time. Whoever has a question, feel free to turn on your video and unmute at that time so that we can hear from you. And then we'll kind of open up the floor and have a conversation. So to introduce our speakers today, Joe, the star of the show, Joe Bergera, actually got his MBA at Booth and graduated in '92. He's now the president and CEO of Iteris, and he joined that company in 2015. With over 20 years of leader experience in several technology companies, Joe is an industry veteran with expertise in the use of technology to solve complex problems in global vertical markets. So he has a ton of expertise to offer all of us today. At Iteris, Joe is an advocate for the use of smart mobility infrastructure management solutions to achieve safe, efficient, and sustainable mobility. In his past lives, he was Group Vice President of Software at Roper Technologies, President of iTrade Network, a Roper subsidiary, and before that, he was Executive Vice President at CCH and at Sage Software. So he will be sharing with us today all his knowledge. And then James Ross is a research data scientist here at the center, where he's hugely impactful. He leads some of our most cutting edge research projects and mentors a lot of our junior researchers. He has a background in applied mathematics, actually, and experience using data science across financial and criminal justice projects. His research primarily focuses on the design and analysis of efficient sampling algorithms. He previously worked and came to us from the Commonwealth Bank of Australia, where he helped develop the CBA-MI financial well-being scales in collaboration with the University of Melbourne. So I am thrilled to turn it over to these guys and excited to learn what they have to tell us about today.
Thank you so much, Emily. Nothing more intimidating than getting an introduction where I think mine is about 1/10 as long as Joe's, but we'll see how we go. Joe, first of all, I want to open up with, given that impressive catalog of work experience, do you consider yourself as more of a technology person or as a business leader in particular?
Yeah, no, I definitely consider myself more a business person, but I've always worked in technology fields, and I wouldn't say that I'm highly technical, but I do think I have a good appreciation for how you can apply technology to solve business problems.
That's great. So what actually drew you into the technology area at first?
Yeah, well, it was kind of just sort of, I guess, a little bit of luck, but when I was studying at the University of Chicago, I went to the school because I was really interested in finance and economics, which are fantastic fields. But it was interesting as I sat through a lot of these classes on finance and economics, there was a ton of discussion about how, new paradigms in terms of thinking about finance and economics had created new financial instruments and really tremendous innovation in the financial sector, and that led to an explosion of growth in the financial sector as well as the broader economy. And it struck me that at that point in time, in the early 90s, as I was starting to think about, my next job, even though I'd gone to school because I wanted to do something in finance and economics, it really struck me that the next big field where we're going to see that same kind of innovation and as a result, the same kind of new opportunities was maybe not in finance, but actually in information technology. And so I didn't know anything about information technology when I graduated from Booth, and I ended up taking a job with a large systems integrator that's since been acquired and doesn't exist under the same brand anymore. and I was fortunate to get recruited into what was that company's information technology consulting group. And so I did a lot of work with both public agencies, but also a lot of commercial clients to help them figure out, what kind of technology investments they needed to make in order to support their business strategy. And so a lot of times we would be working with like McKinsey or BCG might be doing the business strategy and we'd be doing the companion technology strategy. And after a few years of doing that, I thought, consulting is a fantastic thing to do. I learned a whole bunch of stuff that still benefits me a ton today. And I apply it every single day in everything that I do. But I wanted to go work for, I wanted to get out of consulting and go work for a company where I felt like I could create more leverage. And so it was logical for me to go work for a technology company at that point, because I'd been, doing a lot of work with different technology companies as I was researching them to make recommendations for our clients. And so I ended up going to work for one, and one thing led to another.
Okay, that's fantastic. So you said that this sort of started in the early 90s, which I believe is about the time you were graduating from your...
Yeah, it was like 92. Yeah, it was like decades ago.
Fantastic. So what was it that actually made you think that technology was going to be a next big area of innovation for AI?
Well, so I didn't. I mean, AI was not on the radar screen in '92. And so just to be clear and fair to everybody, I ended up working for a lot of companies, initially in business intelligence and then in sort of the application space. And as Emily was saying, most of the work that I've done has been with companies that provide vertical solutions or industry specific solutions. And you can think of application software as being either sort of horizontal. So I would say that customer relationship management, Salesforce automation, marketing automation, enterprise resource planning, those would all be horizontal applications that are used across a variety of different industries. And I've done work in CRM, but generally I've tended to focus more on sort of vertical solutions. So helping manufacturers, information technologies, financial services, now transportation, figure out to develop applications specific to those vertical markets in order to create value for that specific industry value chain.
Oh, fantastic! Thanks.
And then in the last 5 years, I guess, that's really when I started to focus. I have, just to reiterate, I've done a lot of work in business intelligence and data analytics specific for various vertical markets for over 20 years, but it's really only been the last 5 years that I've been doing that much in the AI area.
And the last 5 years, is that the 5 years that lines up to Iteris a lot?
Yeah, actually it does. So yes, I mean there is some AI is something very technical now, but previously, sophisticated statistical analysis might be, some people might have called it something similar to, predictive analytics and might have said, hey, that's kind of AI. But, AI as it's currently defined, yes, I've only been working in that area the last 5 years, and it does line up, with when I joined Iteris.
That's great. And I don't want to get bogged down in a semantic discussion of what AI...
Yeah, it could be like a huge battle here. It'd be really boring for people, but it could be bloody.
Yeah, that's great. What I would like to hear more about, on the Iteris About page, you describe yourselves as the global leader in smart mobility infrastructure management. I've had the good fortune of reading a bit more about that on the page already, but for everyone else on the call, could you give us a quick breakdown of what that means?
Yeah, sure. So historically, there's if you think about it, there's literally billions and billions of dollars that's spent on transportation infrastructure. I mean, just look at the $2 trillion that is being bandied about for the transportation infrastructure stimulus, or the infrastructure stimulus bill. And a lot of that's going to be pick and shovel projects, where you're laying roadbed and putting down asphalt and you're building bridges and whatnot. But that being said, when you think about it on a national level, most of the physical mobility infrastructure, roadway infrastructure, is largely in place. And so, but the budgets remain the same, and they actually even continue to grow. And now we've got this huge potential, stimulus bill. So the question is, now is not like, what are the new roadway networks that need to be built out? Of course, you need to maintain those. But the real opportunity now is to figure out, how do you apply technology to get better utilization of the existing physical infrastructure? And utilization is certainly measured in terms of like throughput. So you want to minimize congestion, but you also want to maximize safety. And so data is becoming really, really an important part of how you do that. And things that all of us interact with every day, it'd be like Google Maps and Waze and Apple Maps and stuff like that. And you're getting information regarding how long it's going to take to travel by different routes, and that's based on probe data, and then which actually we ingest a ton of. We do a lot of analytics on that, and then we calculate based on that information how long it's going to take to move from point A to point B. So if you're in a car, like a Toyota vehicle, and you're using the in-vehicle navigation, and just like with Google Maps or Apple Maps, it's going to give you alternate routes and tell you what the relative time is going to be for route A or route B. That information is coming from us. So mobility infrastructure management is really about taking information technology to understand what's happening on the roadway, in order to help people who are operating that roadway, like agencies, make sure that their signal timing is right. In cases where they have variable speed limits and dynamic pricing, that the speed limit is right and the price is right, and all that stuff's happening in real time. But also, we're facilitating the exchange of information between the physical elements of the roadway and like cloud technology, so that we can share it with people who are traveling on the roadway. And increasingly, we're also starting to do a lot of work with automotive OEMs who want to take information about the mobility infrastructure and ingest that into their cloud, and then share that with connected vehicles, or they want it to be able to pass it directly to automated vehicles, so that the onboard computer of an automated vehicle has the benefit of contextual information, as well as just the information that they can glean from the in-vehicle sensors, in order to make sure that they're traveling the safest and most efficient route possible, and also navigating, of course, like pedestrians and potholes and all that stuff. So smart mobility infrastructure management is really about managing the interaction between the physical infrastructure and the people who are traveling on that infrastructure, and really the glue that holds that all together, or that the interaction. If you think about it like in a technical perspective, it's really all about data. That's how you eliminate the friction, or you create equilibrium between the physical infrastructure and the people who use it.
Okay, that's interesting, and there's a lot that I want to dive into there. First of all, I understand that you've been really successful in this endeavor as well. I understand 40% of signalized intersections use Iteris products, which is phenomenal. You spoke at the end there about really drawing data out of all of this. Is data the end product that you're trying to sell with this, or are you trying to build products on top of the data and sort of sell the information and conclusions from that?
Yeah, that's a really great question, James. So yeah, so like you mentioned intersection detection products. And so, yeah, we have very sophisticated products. They're either camera or radar based, or they're a combination. And so they are monitoring what's going on at the intersection, and then they're digitizing that information. And then we run really sophisticated algorithms in real time. So it's like, super complex edge processing in order to figure out like the optimal timing of the light, for example. So if you're approaching a light and it turns yellow, you're in what we call the dilemma zone. We know the probability that you're going to run that red light, or you're going to run that light. We don't want it to turn red. So, for fear that you're going to get, hit by, someone who's traveling, the opposing direction. So we're going to hold that light yellow, just long enough for you to get through. And, a lot of people like kind of will experience that. You'll go through a yellow light and like, wow, I didn't realize those lights were yellow as long as I thought that they were. That's probably because we held the light for you. But anyway, there's a lot of value in that, the detection alone. But then we also take all that data from, our sensors and we ingest that into our cloud, and then we perform analytics against that. So then, we can monetize that data. But additionally, to your point, we also support a lot of different applications, that come out of that as well. So like one of the things that, an application that we're introducing is called emergency vehicle preemption or transit signal prioritization. So, we can detect, like a emergency vehicle, an ambulance, or a fire engine, because we have AI in our our sensors that can distinguish an ambulance from other vehicles, and then we classify that object, and then that becomes we factor that into the edge processing and determine that it's critical to change the timing of the light so that that vehicle can get gets priority. So the light's going to get changed for that vehicle to get through. And similarly, we can do other things like with transit vehicles too, like buses and stuff, to make sure that they stay on time. But then we can also take that same data and then we can push alerts to connected vehicles or people who are using Google Maps or Waze, to notify them on their application that there's an emergency response underway that could impact their route. And so you're absolutely right. I mean, there are multiple levels to our stack, if you will, with the actual sensors themselves, the data at the next level, and then ultimately the real value comes from the applications.
That's great to hear. Really interesting to see the diversity of applications you're finding for all of this data. One thing I've certainly found in my own work is that the parts of it that I think are sort of impactful and important are not the same things that the people I talk to feel about. So I'm curious, of those, which are the ones that you try and sell the most when you're talking to either a new or an old client?
Oh, that's a really good question. I think that there's beauty in the eye of the beholder, right? So what's valuable to a public agency may be different than what's valuable to an automotive OEM, or what might be valuable to a media company that are also interested in a lot of the information that we collect and the insights that we produce. I think that really the most important thing is to be able to characterize those opportunities, and you try to size them, right? Because everybody has limited resources, and you want to be working against the opportunities that are going to create the most value. And there's both a science to that, but there's also an art. Sometimes it's hard to know the answer to that if you are going to go strictly on available quantitative or even qualitative data, because a lot of people are not even asking the right questions. And so we usually go through a very interactive exploratory process with people that we think are logical users, and tend to develop concepts, and then we try to quantify, kind of measure the value response, the perceived value response, from those people, and try to quantify it. But I have to say that every time we do that, we're still surprised. There's certain things that you think are going to be, we used to say in the BI world, we were going to find that $1 million query, and sometimes you're just wrong. What you think has got a lot of value doesn't produce it, and as you said, sometimes surprisingly, other things that you just think are trivial can really capture the imagination of customers. But I think the key thing is really just to be collaborative, and you need to have an interactive kind of customer-led innovation process to find those opportunities.
Okay, and I'd like to hear actually more about this development process. So you spoke about some sophisticated algorithms earlier, and then sort of improving those. Once you've accomplished the step of sort of identifying the potential for opportunity somewhere, how do you go about the process of producing one of these algorithms?
Yeah, well, so there are algorithms and then algorithms. So like not all of them are really AI, but let's talk about AI. And so I mentioned the intersection detection products that we have, and that we're able to identify, distinguish an emergency vehicle from like a regular vehicle, or an emergency vehicle that has a siren on from one that doesn't, right? And so how do you do that at scale and essentially in real time? You can't do that without AI. So what we were fortunate because we've been in the detection market with these sensors for over 10 years now. So we already had huge data sets, and so what we were able to do is select a couple AI frameworks, and we specifically are focused on convolutional neural networks. Because there are a lot of different kinds, just make sure everybody understands, there's a lot of different kinds of AI. So we were focused on convolutional neural networks, and that means that we're specifically focused on the application of AI to object classification, object recognition. And there are different kinds of AI, right? But anyway, so that's what we were doing. But the benefit that we had is, again, we had these huge data sets. And so we, in our particular case, decided to use YOLO and ResNet, as the framework, and we were able to run that against, literally, a decade of data at tens of thousands of, video at tens of thousands of different intersections to train, that framework and ultimately construct our model. Initially, when we developed like the sort of the first generation model, we got fantastic results, like 90% accuracy, which is, fantastic in a lot of instances. But, in our case, because our technology is used for literally life and death decisions, real-time decisions, we need like 6 nines of accuracy. So we had to go beyond that. So we ended up, identifying, actually using an outside firm, because it just took like way too many resources. We didn't have enough people to do this, to help characterize the reasons for the misidentification, which was about 10%, and then we ended up annotating the video to images that we had, based on the characterization of the inaccuracies that were produced with the initial phase, the first generation of the model. And ultimately going through, just iteration after iteration after iteration, we're now at like 99% plus accuracy, which is where we need to be. But, the answer is it's easy. I think it's easy to get in that, not easy. It's not a lot of people, if you have the basic technical skills and the capital, can get to like 60-70+% accuracy with AI. And in a lot of fields, that may be good enough. But in certain fields, you need to go a lot farther than that. In our case, it took us probably 2 years. And we also feel that, we have a really big moat because, not only are we at least 2 years ahead of everybody else, but no one else has, the data sets that we have. And so I think it'd be very difficult, for anyone to try to replicate, what we've done in our particular field. And I think those are things that people should think about because, right now AI is like a new field. And so, if you get into it, you already have, a lot of, you have a head start on a lot of people. That gives you some degree of comparative advantage, but people will catch up unless you've got something unique. And, so having a unique data set, having unique know-how as to how to apply this, understanding the right questions to ask, those things are what going to really differentiate people in the field. In my experience, is going to differentiate people in the use of AI.
It's such a relief to hear somebody describe the day-to-day tedium of going through some of these models. Thank you.
That's why we outsourced it. It can be really mundane, and it's a lot of work.
Yeah. Also, just for the benefit of, I think most of the people in this audience should be aware, but convolutional neural nets are just a deep learning model that are particularly good at working with image data, which was something that really confounded earlier statistical techniques, which I'm guessing is also one of the reasons that you had a backlog of data and hadn't worked on it up until that point, was that the technology just didn't exist.
Right, it wasn't there, exactly.
Yeah. Okay. Now, I don't think I could get through this whole conversation without talking about the pandemic. So I'm going to go ahead and dive into that for a moment. Sure. Obviously, the pandemic drastically changed a lot of things about the real world. We also know that AI tends to really struggle when it's faced with sort of new data that it may not be familiar with and sort of lies outside the domain of things that it's seen before. Did this present a challenge to you guys at any point?
So in our particular case, the application of AI to the specific business problems we're trying to address, we didn't find any. There were certain changes, but it didn't impact the accuracy of our models. So in that case, we didn't see any impact, but we definitely saw a lot of impact in terms of our product development cycles, because while we did an excellent job, I think, of shifting all of our employees to a remote operating model, some of the work that we do, because it's so technical, there's a lot of very specific tasks, that are assigned to individuals with very deep technical experience, and so there's a lot of handoffs and a lot of interdependencies, and also, in a lot of cases, we're talking about huge data sets, and so there are bandwidth issues and all that kind of stuff. And so the biggest problem for us is that we couldn't have as many people as we wanted co-located in our primary labs, and so that definitely caused delays as far as new product development cycles went. But fortunately, it didn't impact the accuracy of any of the technologies that were already deployed in the field. We didn't see any issues in that respect.
That's great to hear. And then I'm curious about this product development that you're talking about now. So one of the things that I often see is there's quite a big disconnect between the people who are familiar with the data and the sort of things they can do with a set of data, and people who might have strategic opportunities in mind and who are trying to identify certain products that could be developed well. How do you guys come up with ideas for products? So things like holding the lights for a running car may be really obvious in hindsight,
right?
But I think before that product exists, it's not entirely obvious.
Yeah, no,
do you have a process?
And that's the interesting thing. I have a lot of people that are interested in pursuing AI initiatives, and so they'll ask me well, where did you get the resources? Where did you find your data scientists? Where did you find people who are familiar with different machine learning frameworks and whatnot? And I'm happy to try to help them there. Those are huge problems you've got to solve for. But I try to remind them that just finding those technical resources alone isn't going to solve your problem. And so one of the things that we've always tried to do is to create kind of multidisciplinary teams, that have usually industry experts, domain experts on top of that. So not just in our case, transportation or mobility, there are specific fields within, those areas, who understand particular operational or engineering or planning functions. or have familiarity with certain kinds of communication standards and whatnot. And then you also need, like developers, and you need data scientists. And we tend to use an agile development approach, for everything that we do, not just for like writing code, but, even like, we develop like a project is going to start with an ideation phase, and we'll have sprints even during the ideation phase. Where we're tasking these multidisciplinary teams to quickly create stories, and then we'll go through like a prioritization process. A lot of times we'll test some of like the high priorities with actual customers, as I said, because we try to apply a customer led innovation approach. And so that's worked for us, but that's really hard stuff, right? I mean, you can't just go get venture funding and go make that happen. You've really got to get, like at the end of the day, it's all about human capital. And so it's about assembling that, that critical team, that has the mix of human capital that you need. And, it's super hard. And then once you are lucky enough to get that team, you hold on to them, it's like, it's so precious, right? I mean, you do everything you can, to keep that expertise. And, and that's like a whole nother challenge, right? And it's not just about paying people, it's about creating an environment, creating like a vision and a culture, that is going to be meaningful for, for those people. And, who are going to, they find an affinity, for what they're doing. And that's really what binds them to the organization. And that's essential, especially today, because the technical resources are in such demand, and it's so easy for people to walk away. And if it becomes about just economics, you're going to lose, because there'll be somebody who's going to pay more for those skill sets than you're able to. You've got to have another reason that people want to stay with you.
Absolutely. And I think the turnover for most technology professionals is quite fast. Is that right? So I assume you've got to work
is, yeah, and it varies all over the place, and it kind of depends on the particular, like whether you're talking about customer support or sales or development. But yeah, I think in general it's going to be high teens to about 20% on a blended average basis across all these various different functional areas. And fortunately, right now, well, actually, historically, our attrition has been like in the high single digits, so substantially better than the broader industry. And it's something we work at really, really hard.
Okay, that's interesting. So internally, it sounds like it's a big mix of bringing on the right talent, sort of fostering a good culture of innovation and collaboration with these teams, and just having
and as well as with your customers too.
Okay.
Yeah.
I'm interested then. It seems like transport is not necessarily leading the AI trend. Like there are some other industries that have been using machine learning and AI for a little bit longer. Are you looking to these other industries for cues at all?
Yeah, well, certainly we're benefiting from all of the investment, that other industries have put into these things for sure. And yeah, we definitely look at best practices, and we try to reach out to build a network of people who've done work in this area. And a lot of, to your point, James, a lot of times it's in other industries, and so that happens all the time. But I also want to say that the same thing that I said about like when I left Booth and I was interested in going to technology because it was kind of the next new field. I thought it was just a hunch, but fortunately it worked out that way. But that's the same thing with transportation and mobility, right? I mean, to your point, like there was a ton of spending, that went into MRP systems for manufacturing, and like 2 decades ago, there's a lot of IT applied there, followed by financial services, telecom, more recently in healthcare. Like the last really big market, to really apply information technology in a big, meaningful way is probably transportation infrastructure. There's a lot of IT investments gone into like supply chain, transportation, and logistics, but not the actual management of the mobility infrastructure. So I guess what I'm saying is I don't want anyone to feel like, that's a bad thing to draft on other people. It actually, that can be a really good strategy if you can, find those opportunities. And we definitely try to capitalize on that.
Oh yeah, absolutely. And that's not to diminish the work that you've put into developing any of your products either. It's 2 years to develop some of these algorithms is absolutely understandable. That's the effort I would expect, I think. Given that I want to give some time for people to ask questions at the end, I guess we might wrap up by looking forward to the future. So looking to these other industries for cues and just thinking about what the strategic future is for Iteris. Blue sky, what are some of the opportunities you see coming up?
Yeah, well, as I said, there's, in my opinion, there's a need to take the friction out of the interaction between the actual physical mobility infrastructure and then the people who use it. And, there are examples of people trying to do that already with like, to some degree, like Google Maps and Waze and so like those are tools to eliminate some friction. But and I don't want to get into all of the detail, but the mobility infrastructure itself is really, really, really fragmented. There are like hundreds and hundreds of different pieces of technology that are deployed across the roadway infrastructure in any given town or city. And so each city has a highly heterogeneous technical or technology ecosystem, and then you multiply that across all the counties and all the states and all the cities. It's just hugely complicated. So the huge opportunity is to try to figure out how do you become like that single hub. How do you become like the logical nexus point to facilitate interaction or interoperability between all of those discrete pieces of technology, literally millions and millions, very heterogeneous devices that are deployed across, the nation's mobile infrastructure. How do you become the logical hub, for all of that technology to communicate with all of the connected and automated vehicles, that are starting to be released. And I think that most OEMs, automotive OEMs would say, if they're, like really self-honest, that there's really no way of getting to level 3 and level 5 autonomy. And I don't know if everybody's familiar with that. When you talk about autonomous driving, there are 5 levels of autonomous driving. And right now we're kind of at level 1 or level 2. And so when you think of like, hey, I want to be able to just get in my car and say, hey, take me to the grocery store and you don't have to do anything, that would be level 5 autonomy. There's no way to get to level 3 or 5 without the ability for what they call infrastructure to vehicle communication or integration, or sometimes they'll call it vehicle to everything integration. And the only way for that to happen is by having this single hub, because it's just a collective action problem. There's no way that every automotive OEM can go map, their technology to every single city's, thousands and thousands and thousands of unique devices. So there has to be a single point of aggregation. So, our vision at Iteris is to be that platform.
I love the sound of that. I also want to really stress for the listeners' benefit that integrating data silos and like disparate data sources sounds really easy on paper, and it's absolutely not. I'm sure you'll back me up on this.
Really, really hard.
Practically, logistically, just like much more challenging and difficult than I think anyone would expect. That's fascinating. I think I'd like to open it up to some questions from the audience.
Sure.
I don't want to take up all the airtime.
I love that.
So I don't know if the best way to do this is just to drop it in the chat, Emily.
Yeah, I think that, however students are comfortable, you're welcome to jump in and just unmute and turn your video on and participate in the conversation, or you can say something in the chat, or you can raise your hand and I'll call on you. Any of those are appropriate ways of interacting.
I might kick us off with oh, you know what? It looks like Ivy's got one. Why don't you go
got
ahead,
a
Ivy?
hand up.
Yeah, Ivy, please unmute and go ahead.
Yeah, sure. Thank you so much, Joe. Really appreciate the insights. Fascinating learning from you. So my name is Ivy. I'm in the evening MBA program, and I currently work at Blue Cross Blue Shield Association, a healthcare insurance company. So a few questions for you. The first one is, I think there's a lot of companies just keep talking about big data, machine learning, all that fancy term, but normally just stay at that. So when it actually come to the point that adapting and then the infrastructure challenge and then the traditional mindset of knowing, like just doing the descriptive analysis rather than pushing to the next level, I find out leadership have this perspective. It's kind of like a black box. I think at one point we were trying to do a tree-based model and then the leadership come back like, I don't understand what that is. So I felt like I can't trust it. So I wonder, what are some strategy and advice you would give people like trying to push the envelope and try to help an organization be more forward thinking, adapting, more advanced analytics?
I think that's a great question, Ivy. So I have to say that, in fairness to my team, I didn't have to push them. They came to me, right? So I want to give credit where credit's due. But so actually putting myself in the same position, perhaps, as like that head of, your company. What I really appreciated is that people were able to come to me and share with me some examples of how we could actually use machine learning. And you're totally right. I mean, there were a lot of people in our organization that were like, well, we're already very sophisticated in our use of data science, and we're already doing like AI, and and as I was like bantering with James about, I mean, like there is a little bit of a gray area, but if you use a strict technical definition, we just weren't. But we didn't know what we didn't know, and so again, I think the thing that was the most helpful for us was when people brought actual examples to the table, and that's when it really got real.
Got it. That's very helpful.
Now, that's hard to do, though. I know you're like, well, thanks, Joe. Now I got to go figure out how to do that. And I wish I could tell you, how to do that. But I'd say, like, start small, right? I mean, like we started with very specific problems that we could apply AI to, and then it like grew from there. And there's no shame in that. I think it's something you want to prove out, and and I think you'll find that it snowballs, it builds on itself.
Yeah, I agree. I think I just need to be more persistent, just on and off, keep presenting those ideas, and I hope one day like they will kind of get it. Yeah, I really appreciate that. So my second question is about kind of the bad data. So like in healthcare, I think it's around last year, there is a very famous discussion about algorithm bias. And I know our Center for Research Scientists have like St. Hill is one of the leading pioneers to discuss that. So what would be some like practical advice you had for people to counter this, because of bad data? Like I think the original story is because of there are a lot of healthcare algorithms only include data from white people, and the minority is completely being left out. And then the resulting insights really doesn't apply for minority. And I bet that is just a very universal issue. Any practical advice on that?
I wish that I did. And first of all, I'm totally sympathetic. I think it's a huge, huge issue. In our case, because we're, focused on, the use of convolutional neural networking to object, classification and identification, object recognition. It's more of an objective, like, did you get it right or not? There's not like hypotheses built upon hypotheses, right? Where you end up introducing that kind of bias that you see with the data sets that you're working with. And so I personally haven't, had an opportunity to deal with that. But I would say that, someone who I know at the University of Chicago, who's I think really smart in this area, is actually at the public policy school, a woman named Kate Baker, who's the dean of the public policy school.
Yeah, I actually went to her school as well.
Yeah. So at least you're in a good place to find, experts, but it's a really hard problem.
And Ivy, I can share with you after some additional resources on that if you want, since a lot of our work is on bias outside of this. So I can hook you up with some of those people too.
That'll be fantastic. Thank you so much. Really appreciate it.
Yang, did you have a question? I see that your hand is raised. If you want to jump on, please join us.
Right. Hi. So, sorry, everyone. I'm outside. So
it's like a beautiful day.
Yeah, like I was walking and listening to a talk. It's like I was using Clubhouse app. It's pretty fun. Interesting experience. So hi, Joe and James. My name is Yang, and I'm currently just graduated from Master of Science in Analytics program from Chicago, and about to work as a data scientist next month for Project 44. I think my question is, from my past experience as a data scientist, like Ivy said, it's difficult to present your idea to the executives because a lot of time, we as data scientists, we don't know how to present, which means data visualization is a very important part, which is something I'm currently struggle with. And I just want to know, your opinions about how data scientists or even a software engineer make a bigger impact in the team when it comes to data visualization. I think this is very important for a lot of data scientists.
Yeah, and it goes back, at least in our case, to that multidisciplinary team. We had, over the course of the couple of years that we were developing, our AI-based products, a lot of very technical conversations, and it was fascinating. But where we really started to gain traction is when we had the domain and industry experts teamed up with the data scientists to really present the art of what's possible in the context of like practical business problems. And that's really where the light bulbs went off. And so, I think, again, all of the technical presentations that I've had were fascinating, but what really secured the investment, and got the business aligned against ideas was when, they were connected to very practical business problems. So to the extent it's possible, I would say, like, I would try to team up with people who are in the business and, help them, understand how you think, AI could help solve business problems, and then present, the solution, like AI becomes an enabler, to address a problem. And I think that's where, you're going to get, the more traction, because it's just going to be more intuitive to people who, have the decision, the budgets, and, tend to have more decision-making authority.
Thank you so much. I think that helps a lot for me to understand how to approach this in the future.
Yeah, and I know it's hard because, I'll say that, like, our technologists, they tend to spend a lot of time with one another, right? Because they speak the same language and they get so excited about, all the technical possibilities, which are really fascinating. But I think that the technical staff that have really risen to the next level in our organization anyway are the ones that have been able to cross that bridge, and build relationships with people in the business and help, to educate them on how their technical knowledge can help move, their business objectives forward. And that's where I really, really see, like, huge power. And that's where, those technologists, like, really leapfrog in the organization because their ability to do that.
Thank you so much. Appreciate it. Thank you.
Sure.
Yeah.
I think I'll also piggyback on that and ask about so I want to combine the two questions that Yang and Ivy just asked. You were talking about how multidisciplinary teams really help the data scientists make effective presentations. Do you also find, or I guess in my experience, this is also one of the best ways to reduce the bias, is that you'll have data science teams who typically to fit a model will doggedly pursue one specific metric, while the multidisciplinary people, I guess, have often a better understanding of what the real world implications of that are.
Yeah, no, actually, I think that's a really great point, and it's a great answer for Ivy. Yes, I totally see that, because, we'll be in a room and people will say, well, of course, the model, said that, but it's wrong for, these reasons. And yeah, it would not be intuitive to, the technical staff, just because they don't have the benefit of certain context, that people in the business can bring. So I agree. I think it definitely can help address some of the bias for sure.
Fantastic. Since no one else has got their hands up, I have like a million questions. I can do this.
Okay, but we don't have to keep everybody either. but I'm good for another 8 minutes. And I've really enjoyed the conversation.
So I actually have one more question, if that's okay.
Sure.
Yeah. So my other question is about the cost of building a model. So with that being said, basically, when you use CNN or ResNet, we're talking about cloud computing. We talk about huge amount of cost when we actually processing those data. We can talk about thousands or hundreds or even millions sometimes. And I want to know, how do you guys decide to approach this specific model when there's a significant cost under it, which means like if you failed, it's a huge chunk of money that you just wasted, right? So I really want to know, how do you guys looking to evaluate the data even before it's implemented? Or model or idea or whatever things it is.
Yeah, that's a really great question. So in our case, we always try to set the industry benchmark in terms of, feature capability, product performance. And, as we're talking about, there hasn't been a lot of, examples of the application of AI in the particular areas in which we're working on. And so, we wanted to be sort of the first to market, with a real viable solution. So it was kind of it was a strategic decision that we made, and we went into it not sure what the payback, well, first of all, whether it would work, the approach would yield anything meaningful. And then we also didn't know, what the economic value would be. So, we just made a decision to do it because we felt it was important, and if we didn't do it, we're concerned somebody else would, and we didn't want to cede our leadership position. And it ended up in our case being, we wrapped the application of AI into some other activities that, we were already planning to do, but probably just the AI aspect alone was, probably at least 2.5–3 million dollars at least. But we got a lot of efficiencies because, we were introducing a new, technology platform anyway, and we were able to incorporate it into that. But anyway, the logic, in our case was that, we were trying to protect our market position. And therefore, $2.5 million, that it was well worth it. And I'm sure other people might make the decision differently, but that was our basis for the decision.
Thank you. Yeah. So my previous job was a startup company, and they count every single dollar. So that's why it's really, really hard for them to, like I'm trying to tell them, hey, using deep learning, and then they said no, like we're gonna go with tree-based because it's much cheaper to train. And but yeah, thank you so much for your answer. Really
of course. Yeah, and every company is at a different place, and so the decision calculus is different.
Thank you.
I wanted to, just before we end, Joe, I had one thing that I wanted to ask really quickly, was just for our students who are current MBA students who might be interested in joining the field of AI, what do you see as maybe the most beneficial quality of leadership in AI, or what is something that they could work on developing that you think will really serve them well in this particular field?
Yeah, sure. Well, that's a great question. So I guess I'd go back to this whole multidisciplinary thing that I've been talking about. And so I guess my message would be that applied AI kind of by definition requires, this multidisciplinary approach. And therefore, you could find yourself doing things in the field of AI with a lot of different backgrounds, and interests, right? So you could, be, you could have come through, like the sort of software development route. You could be like maybe a PhD with an interest in data science. You could also be, someone with industry, knowledge, or certain domain expertise. So I think that everyone can and actually needs, to contribute to successful applied AI efforts. I don't think you could ever be successful with strictly, a technical team. So that's the first thing. But anyway, if I were coming out of school and, and I had more of a business background, for example, like I did, I think a really good launching pad would be like a role in product management, for example, in a technology company. Also you could go work in like healthcare, like Ivy is doing, or, financial services. And, there would be like new product organizations, that would probably have product managers or product line managers. And so that could be an opportunity. Potentially there'd be like an internal, IT organization that serves as a shared service, that could make sense as well. And again, in any technology company, I think, a role in product management would be a great stepping stone.
Yeah, that's awesome. And I know that there are some really great organizations out there that that use like the APM role to kind of grow and develop staff who are newly graduated into even more impactful roles. So that makes a ton of sense to me.
Oh, absolutely. I mean, I think of product managers as like basically mini general managers, right?
Yep.
It's a very multidisciplinary job. I think it's a fantastic launching pad for, anyone coming out of business school with an interest in technology. But just so you guys know, I actually, I went into technology, I did consulting, and then from there I went into marketing, and then from there I went into general management. So, there's so many routes, to get wherever you want to go. And I think the key thing is to just have a vision and generally know it's going to take like 3 to 5 years, to move from one step to another. And you have to accept that, but always be planning to move forward and know kind of where you ultimately want to get.
I think that's excellent advice. I want to be mindful of time. I know you have a very busy schedule, so we won't keep you anymore. Thank you to everyone who came and listened. I know that everyone is busy, so I'm planning. I'm so sorry about my cats in the background, by the way. We have a couple extra attendees.
And Emily, it looks like a couple people may have had some additional questions. So feel free to share my contact information with people if you want, and shoot me an email, and I'm happy to follow up with anyone. It's been a pleasure talking to everybody, and good luck. It's exciting. I wish I were in business school again. You have so much opportunity in front of you.
The world is ahead of them. Okay.
Absolutely.
So you'll hear from me soon. Thanks, everyone. Thank you so much, Joe. Thank you, Jane.
Bye-bye.
Bye-bye.